Hello, this is Sharon from SAS Statistical Programming. In this tutorial, we're going to look at the GLM procedure for investigating mean differences. This is the GLM procedure general form. We're going to explain the statement in detail when we look at the SAS program. Consider the following application of the analysis of variance procedure. We have a reading score data set. Each student has their corresponding reading scores represented by variable rate score, and we did survey to collect some information. One of the information is regarding parents' highest education represented by variable PEDU. And the PEDU has three categories. 1 equals below college, and 2 equals college, and 3 equals graduate school. We want to test whether or not the student reading scores differs across various groups of parent education. Therefore, the hypothesis to be tested is mu1 equals mu2 equals mu3 versus not all mu i's are equal, where 1, 2, and 3 corresponds to each group of PEDU. Now let's look at SAS program for GLM procedure for investigating mean differences. First, we need to get the data set ready for later analysis. Here I include this lab name statement to invoke the library model. Okay, and then I use this import procedure to bring in the Excel data set, which is analysis underscore data, and then create a permanent SAS data set, ANOVA underscore data. We're going to use this data set for this chapter, ANOVA, okay? And then I use data step to create a temporary data set, AD, from this permanent data set. I also include the proc format procedure because in one of the variable in the data set, which is PEDU, this variable has three categories, 1, 2, 3, and I use format to label those three values, okay? Let's run this part of the program to have the data set ready. All right, let's go back to the code window. First, we need to explore the data to get the overall description of the data, including a preliminary view of group mean differences, as well as visuals of normality and the equivariance assumption, as well as outliers. Here, I use proc sort procedure to sort the data AD just generated from previous program, and then by this PEDU. This PEDU is the parent education information, okay? And then I use this proc means procedure to get the mean of rate score by PEDU, okay? And then lastly, I use proc SGplot to obtain the box plot for rate score by PEDU, okay? So let's run this part of the program and let's look at the results. The first table is the output from mean procedure. So we can see we have a statistic for rate score by PEDU. Okay, let's look at the mean. We can see the mean for below college, which is 69, and college 73, and graduate school is 78. We can see the graduate school is greater than college, college greater than below college. Okay, and then let's look at the plot, which is from the proc SGplot. This is box plot. For below college, it's almost symmetric, and a little left skewed with the lower whisker is longer than the upper whisker. And then for college group, it's left skewed because the median is above the center of the box. And then for graduate school group, it's left skewed with outliers corresponding to the low reading score at around 40 to 50. Okay, let's go back to the code window. In order to infer two differences in the population, the analyst must test the hypothesis in one-way ANOVA. Here we include the proc GLM procedure. We apply this procedure to data set, which is AD, and to test the mean differences across groups. This class statement defines the categorical grouping variable, which is PEDU, okay? And the model statement defines the numerical variable, which is rate score, to be tested as a function of PEDU, okay? And then let's run this proc GLM procedure and we can look at output. This is the output from the GLM procedure. First, it has a class level information. The class variable here is PEDU. It has 3 levels, and it has corresponding values listed here. And then for number of observation read is 200, and number of observation used is 200. When those two numbers equal, that means we don't have missing values on any of the variables included in the analysis. Okay. And then let's move to the ANOVA tables. For this first table, let's look at the degree of freedom. For model, it's 2, which equals 3 minus 1. 3 is the group number, okay? And then for the arrow, it's 197, which is the total number of sample size, which is 200, minus group number, which is 3, so which gives 197, okay? And each mean square is obtained by taking the sum of square dividing by their respective degrees of freedom, okay? Finally, the F-test statistic, which is 3.72, is calculated by dividing the mean square model, which is MSA, divided by mean square error, MSE here, okay? And the F-test statistic has a p-value as 0.026. which is less than 0.05. Suppose we use 0.05 level of significance. Because this p-value is less than alpha equals 0.05, the null hypothesis is rejected. In conclusion, based upon our data, there is evidence in the population that reading score differs across the parent education group, which is PEDU. Okay? And for the rest of the table, we're going to explain in later tutorial, okay? Let's go back to the code window. All right, this is it for this tutorial. We look at how to use GLM procedure to investigate mean differences across groups, okay?